In this video, I'm going to show you how to scrape financial data from Yahoo Finance, demonstrating two of my favorite methods for scraping data, using hidden APIs and extracting embedded JSON formatted data, which can be easily converted to a Python dictionary. Let's get started. For this project, we're going to use several standard Python libraries, such as Ray, JSON, CSV, from IO, import string IO. We're also going to use BeautifulSoup and requests. So if you don't have these already, you'll need to install BeautifulSoup with pip install bs4 and requests with pip install requests. Navigate to Yahoo Finance and enter the stock ticker of a company that you want to scrape. You'll notice there's lots of interesting data in multiple tabs to choose from, but today we're just going to focus on a few of these tabs, but you can replicate this process for any of them that you wish. I'm going to copy the URLs of the tabs that I want to scrape: stats, profile, and financials. I'm also going to extract the historical stock data, but I'm going to access that in a different way, so we'll leave that one for now. You'll notice that all of these URLs have a very similar format, so all we need to do to make these templates is to replace the stock ticker symbols with curly braces. This will allow us to insert whatever ticker symbol that we want with string formatting. Now let's assign the letter F to the stock variable, since I'm going to be looking up the data for Ford Motor Company, and F is their ticker symbol. The first thing that I want to do today is scrape the financial statements. Now, if you go back and look at the web page, you'll notice that we have several financial statements available: income, balance sheet, and cash flow. Additionally, you have the option of getting quarterly and annual statements, and all of these data will be available to use with our GET request, even though it shows right here that you cannot download it directly. Alright, let's use the financials URL template in our stock variable to request the data using the requests library. We'll assign the response to a response variable. Next, we'll parse the HTML data using BeautifulSoup and the default HTML parser. To show you what we need to do here, let's take a look at the raw data. So go back to the web page, right-click, and then click View Page Source. There is a lot of messy stuff on this page, and actually very little HTML to scrape. However, at some point when you scroll down this mess of code, you'll notice what appears to be JSON formatted strings. Now what's happening is that the web page is dynamically loading this data from these JavaScript functions contained within the script tag. Fortunately for us, there's a comment that's appropriately commented as data. This will contain all of the data that's dynamically loaded onto the page. Now, because this data is embedded in a JavaScript function, what we actually have to do is get the script tag first, then extract the contents from it, chop the edges off so that what we're left with is just the JSON formatted string, which we can then convert into a Python dictionary. Because there's nothing really unique about the script that identifies it as a tag, I'm going to need to use a text pattern with regular expressions. Now, if you haven't used regular expressions before, this is going to be very basic. What we can do now is use this pattern to find a script element that has text that matches this pattern. We're going to return the contents of this element, and this returns as a list, so you'll need to grab the first and only item in the list. If you print the script data, and I'm going to print the beginning and the end of it, you'll see that we've successfully identified the correct script. The problem now is that we have this JavaScript code wrapping the data that we actually want. But this is easy enough to fix. What we need to do is find the boundaries of this slice. So at the front end, we're going to use the word context, and then on the back end, we can see that the string starts about 12 characters from the end. The starting position will be 2 characters behind the beginning of the word context, and then we'll go 12 characters from the end, which is indicated with this -12 in the slice. We can then pass this sliced text into the JSON loads function, and what it should give us back is a Python dictionary. You can explore this in more detail if you want, but the data for the financial statements is located in context, dispatcher, stores, quote summary store. And if you use the keys method, you'll be able to see what's available here. Now, the great thing about this is that it contains both the annual and quarterly statements. I'll go ahead and copy and paste the addresses to them all here. But what we're going to do is explore the income statement as a pattern, and then I'll show you how you can easily apply that same pattern to every other financial statement. We're going to use the annual income statement variable, and it contains a list of financial statements that I get from the JSON dictionary. Now, each statement also contains a list of dictionaries, mostly, that contain the account name and a variety of number formats. Consolidating this data is fairly straightforward. For example, if I want to grab the account and the raw number format, I can use a for loop. Because some of these accounts do not contain data or do not contain a dictionary, in this case I need to handle the resulting type error or key error. As you can see, with a simple loop, I'm able to extract only the data that I want into a list of accounts that I can then export to a CSV file. Now this model can be easily applied to any of the other financial statements by simply changing the variable names and references. And you'll see really the only difference is that I'm changing the variable names. Now that you've seen the financial statements, let's look at how to grab the profile data, such as company officers, compensation, etc. Believe it or not, we can simply copy and paste most of what we've already done and just change the URL to profile URL template. Similar to the previous example, most of the interesting data here is located in quote summary store. Within that, most of the information you'll want is in asset profile. But summary detail and SEC filings are also worth exploring, and I'll show you briefly what's in there. The company officers are located in company officers within asset profile. And you can see all the information you'd expect, including pay, name, title, age, etc. You can also look at the company description, which is located within long business summary. Another thing you can get here is the links to the SEC filings on Edgar's. This is in quote summary store under SEC filings and then filings. You'll notice here there's a URL. This takes you directly to the Edgar's website where you can explore this filing further. There's also a lot of summary details that you can get from quote summary store under summary detail. I'll print those here and I'll let you explore them on your own. All right, let's look at the statistics data. I'm literally going to copy and paste this block that I created for the profile page and change the URL. Most of the interesting data here is located in the quote summary store under default key statistics. And I'll print that here for you to see what's available, and I'll let you explore it on your own. Last but not least, let's extract historical stock data. Now, if you look at the historical data tab, you'll see that there's a table here, and to the right there's a download button. And you could click on that button and download the file. But what this actually does is connect to an API that returns data in CSV format. So go ahead and right-click on the button and copy the link. And then we're going to paste this link into our code. This is an API call. You can tell by the not so obvious query prefix, the API version, and the parameters used in the query. So if I use a GET request on this stock URL, what I get back is a CSV formatted data, which I can save to a CSV file or show on the screen. However, what I want to do is make this API call more customizable. What if I want to look up different stocks or use a different range of time or a different granularity of time? The first thing that I can do is split the query parameters from the URL and put the query parameters into a Python dictionary. We can actually customize these parameters even further by removing the period parameters, which are simply timestamps, and then we can replace them with a range parameter. And the value I'm going to set this is 5Y, which stands for 5 years. So what I'm requesting here is 5 years of daily stock data. So how did I know that I could use the range parameter instead of the periods? The key here is to take a look at the network activity on the web page and investigate this hidden API. So go back to the website and click on the summary page. Then we're going to open up the developer tools. which you can do directly based on your browser, or often you can right-click and then click Inspect. At the top right, you'll notice a section called Network. If there's any API calls being made, they will show up here, specifically under XHR. XHR is a JavaScript object that's used to transfer data between your browser and the web server. So if you click on some of these items, you'll notice that a new screen reveals the headers and also a response. And what I typically do is look for a response that appears to be in JSON formatted strings, such as some of these. I then go to the headers to see what calls are being made and also what parameters are being used in that API call. However, we actually already know what the API call looks like, so we can simply look for something that looks like it, and then we're going to check out the parameters. So here's one that uses the v7 API, and you'll notice that the parameters are slightly different. Now, because this is a hidden API, really the only way we're going to get to know how to use it is by exploring and experimenting. We know that it accepts a range and an interval, so one clue to finding out what values we can use for these parameters is to simply look at the filters on the page. Now, from my experience, the Chart tab seems to have the best clue as to what is available. You can see several of the values here that are available for range and several of the values that are available for interval. Now it's just a matter of plugging these in and seeing if they work. Another way of finding out how to use this specific API is simply to make a mistake. And fortunately, this API gives you feedback. And that, my friends, is how you scrape financial data from Yahoo Finance. If you enjoyed this video, you may enjoy some of the other web scraping videos in this series. Please hit that like button and subscribe for more content like this in the future. See you in the next video.